Okay, for the first one, if I think of this, and I go ahead and divide, you divide by subtracting the exponent. So 2 minus a half gives us x to the 3 halves. 1 minus a half gives us x to the 1 half. And then 1 over x to the 1 half is x to the negative 1 half. Was everyone able to get it down to this form?
Yes.
Once you get this, you still have to anti-differentiate. So I had quite a few who got this on whatever, this was a couple quizzes ago, and then stopped, right? But you got to keep going. So this would be 2/5 x to the 5 halves plus 2/3 x to the 3 halves plus 2x to the 1 half plus c. Please don't forget plus c, right? That's just, you might as well just take 6 points and subtract them right now if you're going to not put plus c. Yes?
Okay, so when do you put the plus c on, like?
You put the plus c whenever you take a general, an indefinite integral. And you put it once you take the antiderivative.
Okay.
Yes.
But
So not here, but as soon as I remove the integral symbol and I'm taking the antiderivative, there's my plus c.
okay, so only indefinite.
Only indefinite. If we're going to plug numbers in, there's no plus c.
Okay.
Good question. Any other questions? All right, so for this one, this is a u sub. What's u?
U equals
1 minus.
Beautiful. du is the derivative of u, so it would be what?
negative 6x dx.
Okay. We don't have any negative 6's, so I'm going to divide out the negative 6. A few people are getting upset about the coefficients. I don't know if I would use the word upset, but there's some angst with coefficients. If the 2 is bothering you and you don't want to just bring it forward, you can go ahead right here and multiply both sides by 2 so that you get the 2x dx right here. So if I do that, I have negative 1/3 du equals 2x dx, and now I'm covered, right? Now I'm totally made in the shape. So here's what we've got.
It's not a real expression.
This right here, this is u to the what?
1/2.
U to the 1/2. And then 2x dx equals negative 1/3 du. So you replace 2x dx with a negative 1/3 du. I saw on the quizzes a lot of people felt like they had to solve for x every single time. You do not do that. The only time you have to do that is if you can't replace everything in here with what you have with either your u or your du. But if you can replace it, then you're good. Just replace it and be done. So then if we take the antiderivative, we get negative 1/3 times 2/3 u to the 3 halves plus c. And we end up with negative 2/9 1 minus 3x squared to the 3 halves plus c. Any questions there? How do you feel about that? If you can get to this step, you're golden. Okay, so being able to rewrite the integral in terms of u, that's the most important part. We are going to do a special case, but before we do that, I want to do a quick absolute value, just to make sure we're okay with that. Unless you guys have specific things you want to ask me about.
No,
If you don't need absolute value, we can skip
No,
that.
absolute value is everything.
Absolute value is good?
Yeah.
Okay.
hate that.
You know, you didn't used to hate absolute value before this class, did you?
Oh, I did.
I did.
You always did?
It always did.
Oh, okay then.
It's desire to always be positive.
Very damn
Okay. I don't care, I'll do 9 or 10. Which one do you want?
9.
9.
10.
9.
10.
9.
She's saying it louder.
Do the harder one.
They're identical. They're honestly just identical.
Oh, yeah.
Okay, so here's what we have. You have to be able to write
That's what I was trying to
the absolute value as a piecewise function. First thing you do is you find your splitting point. You set what's in here equal to 0, and you get x equals -2. So we're going to have something for x greater than -2, and for something for x less than -2. If we pick a number bigger than -2, like 0 or 8 or whatever's in the absolute value is positive, which means the absolute value is not even necessary for x is bigger than -2, and we can just drop it. If we pick a number less than -2, like -12, we get a negative inside the absolute value. And the absolute value would serve the same purpose as multiplying it by -1. So you get negative whatever's in the absolute value, which I'm going to think of as -x minus 2. Okay, here's the thing now. We have this integral from -5 to 6. But this function is valid for all x's less than -2, and this is our function we use for all the x's bigger than -2. So we have to split up the integral, and we do an integral from -5 to -2 of the function that applies for that interval, plus the integral from -2 to 6 of the function that applies for that interval. ¿Comprenden?
See.
Okay. And then you can go from there, right? You just -1/2 x squared minus 2x from -5 to 2, and 1/2 x squared plus 2x from -2 to 6. Okay. Hey, let's take a look at number 11 for a second. Number 11, you are given an acceleration function, and you have to find velocity and position. Well, velocity is the antiderivative of acceleration, right? And position is the antiderivative of velocity. Right? Because going forward, derivative of position is velocity, derivative of velocity is acceleration, right? So we're just going backwards. Do you guys remember a week or two ago when we had f double prime, and then you had to find f, and you were given some little bits of information, and you had to like do a plus c and a plus k kind of stuff? That's this, just with names. That's this. So for this, everyone take a second. And here's acceleration. See if you can write your velocity function. Just with a plus c. Just take a second.
Got that.
Got that?
Yep.
Awesome.
Yepers.
All right. Is there any information we have that can be used to solve for c?
-1, 9.
Yes, v of -1 equals 9. So if we plug a -1 in, we get -4 plus 9 plus 4 plus c equals 9. Now what you end up with when you do all of this is you end up with 9 plus c equals 9. So c is just 0. Bless you. Bless you. So our velocity function is just this. Other questions? Does that make sense? Everyone take a second now using this and find the position function. What should I use for my unknown constant here? K. Yay! Because I can't use C since I've already used it in this problem. Okay,
C1.
and you could use C sub 1 and C sub 2. So now I know x of 1 equals 3, so I'm going to go 1 plus 3 minus 2 plus k equals 3. So you get 2 plus k equals 3, k is 1, and then you just rewrite, right? Make sense? Those are fun. You okay?
A long equation.
Yeah, yeah. A quick little nod out to the last problem on this worksheet, and then we'll go back and do a special caser. This is a cute little graph. It's got a semicircle, some triangles, and some squares. We want the average value of f on the interval from -2 to 5. Well, average value would be 1 over 5 minus -2 times the integral from -2 to 5, right? How would I find the integral from -2 to 5 of this function?
Trapezoid formula and just the semicircle.
Areas, right? Areas. So I do triangle plus square plus triangle, or, yeah, trapezoid, but triangle plus square plus triangle minus the semicircle plus the triangle plus the square. Why minus the semicircle?
Because it's negative.
Or you could just do
y.
3 squares plus 1 minus semicircle. Because it's 2 triangles. 1 plus the
Okay, yes, you could. Yes. Geometrically, yeah. However you want to puzzle the pieces together is fine. Okay. All right, so that's that. And let's go back. Any issues on SFTC?
No.
Everyone feels okay with that? Okay. All right, special case. Number 5 is the only special case u-sub on this sheet, which makes you think out of 11 problems, if there's only one special case, there's probably not going to be a million special cases tomorrow either, right?
How many
So
problems
don't
tomorrow?
special caseify everything. There's 10 tomorrow. Wow, and isn't that interesting? There's 11 on this sheet, there's 10 on your test
So
tomorrow.
that means that there's
So
probably
about
gonna be
It's
one.
gonna be the exact
one
font.
of
except
each
for the
type,
graph.
except there's gonna be only one absolute value, probably.
Jen, teach you
What is u for this question?
7 minus x.
7 minus x. By the way, this one, way harder than what's on your quiz.
wizard test.
Or test, sorry, major exam. Okay.
Major
What,
exam.
what's du?
Negative dx.
Negative dx. There is no negative here, so I'm going to move the negative away from the dx. So if we rewrite, here's what we have so far. This term is equal to u to the 1/2. U to the 1/2. dx is negative du. I got that, I got that. Do I have any x squareds that I can apply?
7 minus u.
Ah, I'm going to have to figure it out, right? Okay, this is why this is a special case, because once I've substituted my u and my du and I still don't have everything covered, then I got to solve. So if u is 7 minus x, that means x equals 7 minus u. But I don't want x, I want x squared.
Oh
So I have to
my God.
square this. That's FOIL, right? 49 minus 14u plus u squared. And that's what has to go in here. 49 minus 14u plus u squared. Now, should I just take the antiderivative of this and the antiderivative of that and multiply them together?
No.
You gotta multiply them together first. You have to, you can't, there is no product rule for integrals. You've gotta multiply them together. So we have negative 49u to the 1/2 plus 14u to the 3/2 minus u to the 5/2 du. Now you can take the antiderivative. All right? Okay, tomorrow morning